the shortcut that I had taught you. So let's not even use the shortcut. Let's just multiply. When you're multiplying, you multiply the outside numbers. So 3 times 3 is 9. And then you multiply the inside radical numbers. So you're going to get root 7 times root 7 is the square root of 49. So let's do it the longer way, since I think the shortcut might have confused some of you guys. Okay, but this is not my answer because we always have to see if we can simplify that radical. So 49 gets broken down into 7 and 7. Isn't that a pair? So now I have a 9 on the outside. Let's bring this up here. So I have a 9 on the outside, and now a 7 is coming on the outside. Is there anything left over inside the radical? Nothing. So now you're left with 9 times 7, which is 50. Oh, not 56, 63. All right, for number 2, we need to simplify. So I have 120. I'm going to break that down. Because it ends in a 0, doesn't that mean 10 goes into it evenly? So it's going to be 12 and 10. Now we're still looking for pairs. So for this 12, I'm going to go 6. I'll go 6 and 2. For the 6, I'm going to go 3 and 2. And there's a pair of 2s. Does it make sense for me to break down the 10? No. Why does it not make sense for me to break down the 10? We're not getting another pair because 10 is just 5 and 2, and there's nothing else to break down, so there's no more pairs. So now a 2 is coming on the outside. 1, 2 is coming on the outside, but what's already on the outside? A 3. So we multiply them. 2 times 3 is 6. Now on the inside, what's left over is a 10 and a 3. So now you multiply 10 times 3 and get 30 on our inside. Now for number 3, we're solving. And remember, when we're solving, we have to account for plus minus. So first we have to do all the squared. So 4 squared, I hope you remember, is 16. Plus x squared equals 8 squared, which is 64. Now, before I square root, I have to get the x squared by itself. So I'm going to subtract 16 on both sides. So we're going to have x squared is equal to, well, I can't take 6 away from 4, so I'm going to borrow. This becomes 14. This becomes 5. And I have 14 minus 6 is 8. 5 minus 1 is 4. Now that the x squared is by itself, now I can square root both sides. So x will equal, who remembers when we're solving and I square root both sides, what do I have to put in front? Plus minus, you got it. So we're going to have plus minus the square root of 48. But now I have to simplify 48. So I'm going to break down 48. I bet most of you would do 6 and 8, which I'm okay with. And then 6 becomes 3 and 2. 8 becomes 2 and 4. I have a pair of 2s right there. Should I still break down that 4? Absolutely. So we'll get 2 and 2. Bring it up here. We'll have x is equal to plus or minus. 1, 2 comes on the outside. Another 2 comes on the outside, and you multiply them. So that's a 4 root 3. That's 2 answers right there. We'll skip number 4. We'll get into today's lesson. All right, so the Pythagorean theorem. What the Pythagorean theorem tells us, if we have a right triangle, how do you recognize that a triangle is a right triangle? What must be in it? Thinks they remember. What must be in a triangle for us to say, okay, we know for certain this is a right triangle? A right angle. Bella, was that you? Great. It has to have a right angle in it. Now, when you have a right triangle, meaning it has a right angle in it, the sides have names. The side across from the right angle is called the hypotenuse. Have you guys heard that before? Good. So the side across from the right angle is the hypotenuse. And now the other two sides that are not the hypotenuse, those are called the legs. They're not the same though. So I'll call it leg 1 and leg 2. It doesn't matter. It does not matter which one is leg 1, which one is leg 2, as long as we recognize they're not the same. They can be the same, but they don't have to be the same. And so now what the Pythagorean theorem tells us is if I take leg 1 square, if I take leg 1 and I square it, and then I put a plus sign and I take leg 2 and I square it, that's going to equal the hypotenuse squared. Now, I bet you guys have never heard of this before in your life. Leg 1 squared plus leg 2 squared equals the hypotenuse squared. But what you may have heard of is a squared plus b squared equals c squared. Has anybody heard of that before? A squared plus b squared equals c squared. Okay, maybe a few more people. Okay, these are the same. These are both the Pythagorean theorem. Leg 1 squared plus leg 2 squared equals hypotenuse squared. Everybody almost ever uses a squared plus b squared equals c squared. I'm always hesitant to use a squared plus b squared equals c squared because in order for this to work, you have to remember that c is always the hypotenuse. So we can put a star here, say need to remember c is always the hypotenuse. So what a lot of students like to do is they always like to make C just the missing side, but it's not just the missing side. It always has to be the hypotenuse, which may or may not be the missing side. And you'll understand when we do a problem. So I'm absolutely fine with using a squared plus b squared equals c squared as long as we recognize C has to be the hypotenuse. Now, once I identify C as the hypotenuse, it does not matter which remaining side is A and which one is B. We could say this is A and this is B, or B and then A. It doesn't matter as long as C is the hypotenuse. Okay, so I think I have left you in suspense long enough. Let's see how we use this formula. All right, so the directions say, find the missing side of each problem, simplify all answers. Remember, the Pythagorean theorem that a squared plus b squared equals c squared only works if it's a right triangle. And how do we know if it's a right triangle? It must have a right angle in it. So all these problems will have right angles in it. Don't you worry. So now I have to recognize that which side has to be c. The x this time is c. Now, once I identify that the x is c, doesn't matter which other the remaining sides I label a or b, doesn't matter. So I'll say 3 is a and 4 is b. And now I'm going to use the formula. The formula tells me a squared plus b squared equals c squared. And now we plug in. Well, a I labeled as 3. So we're going to have 3 squared. Oops. 3 squared plus b is 4, so plus 4 squared equals c, which is x squared. So let me color code this. So we said a was 3. We said b was 4. And c was x. And now this brings us back to what we were doing and what we just had our quiz on. We have to solve this. So this is why I spent all that time practicing. So before I square root both sides, I have to simplify. So we have 3 squared is 9, plus 4 squared is 16, equals x squared. 9 plus 16 is 25, equals x squared. Now that we have the x squared by itself and just one number on the other side, now we can square root both sides to solve for x. And then when I square root this, isn't 25 5 and 5? That's a pair. How many 5s are coming out? Just one. Anything left over? No. So now, technically, based on what we learned from before the quiz, shouldn't this be plus or minus 5? But can I ever have a side length that's -5 units long? No. So for that reason, when we're doing these problems, we could just write the positive value. We don't have to show the negative at all. We could just show positive. If you put negative, then you'd have to reject the negative and say this can't be an answer. And if you left the negative, then I'd mark it wrong. So we figured out the hypotenuse is how long? 5 units long. Now, do you think the missing side will always be the hypotenuse? No. So let's look at number 2. This time, which side is C? Perfect. So this is C. 7 I'll say is A, and X I'll say is B. And so our formula is A squared plus B squared equals C squared. And now we plug in our numbers. Well, A is 7, so I'm going to say 7 squared plus B is X, so plus B squared equals C squared. Well, C is 8, so I'll say 8 squared. The biggest part of this is plugging in the numbers in the right spots. Is everybody okay with how I got those numbers? Okay, so now we have to do all the squareds. So 7 squared is 49. 8 squared is 64. I can't square root. Why can't I square root both sides yet? What do I have to do first? Move that 49. You got it. I have to move that 49. So now we have x squared is equal to, I have to borrow. This becomes 14. This becomes 5. 14 minus 9 is 5. 5 minus 4 is 1. Now can I square root both sides? Yes. Am I going to show a negative answer? No. Why can't it be negative? Because sides can't be negative. Is there any pairs in 15 for me to simplify? No. So x is the square root of 15. That's my answer. Before we do 3 or 4, I want you guys to try one on, well, actually, let's just do 3 and 4. All right, so number 3, do we all agree that C is 8? And then I'll say A and B. So now I'm going to have 2 root 3 squared plus x squared equals 8 squared, because I'm using A squared plus B squared equals C squared. So now this one's a little bit more annoying because I have to square a radical. So we're going to have to write that out. 2 root 3 times 2 root 3. Noah, tell me, how do I multiply these? Okay, so tell me, what do you get? And what do you get? 4, just regular 9? Square root 9, you got it. 4 square root 9. But isn't 9, can I break that down into 3 and 3? So now 1 3 is coming on the outside and I have a 4 on the outside. So doesn't that make it 12? Is anybody confused with how I got the 12? Because I can re-explain that. Okay. Okay, so now I have 12 plus x squared equals 8 squared, which is 64. Jack M, can I square root both sides now? What should I do? Subtract that 12. So we're going to have x squared is equal to 52. Now we square root. I can try to break the 52 because it's even. I can say, okay, well, 2 goes into 52. So 2 goes into 5 twice. 2 times 2 is 4. Bring down the 6. 2 goes into 6, 16. Oh, sorry, why did I bring down the, not bring down a 6, bring down the 2. 2 goes into 12 6 times. So I can break 52 down into 2 and 26. And because 26 is even, I can do, again, divide by 2. 2 goes into 2 once. Subtract, bring down the 6. 2 goes into 16 8 times. That's wrong. It's not 8. What did I do? 2 goes into 2 once. Sorry. 3 times. 2 goes into 6 3 times, not 8. 2 minus 2 is 0. There we go. Sorry, I messed that up. So this becomes a 2 and a 13. Can I break down 13? Nope. So there's my pair. Do I say plus minus? No, because a length can't be negative. So we're going to have 2 root 13. Okay, guys, so I want you now to try number 4 on your own. Okay, so your setup should be 2 root 10 squared plus x squared equals 11 squared. How many people got the setup correct? Wonderful. Now we have to actually multiply these. So 2 root 10 times 2 root 10 gives us 4 root 100. But then 100 is 10 times 10. So we're going to have 40 plus x squared equals 11 squared. Who remembered what does 11 squared equal? Excellent, 121. Now I can't square root until I subtract that 40. So I subtract 40 on both sides. Now I'm going to have x squared is equal to, 1 minus 0 is 1. I need to borrow here. So this becomes 12 minus 4 is 8. Now we square root both sides. And I'm going to have x is equal to 81, I could split into 9 and 9. There's your pair. So x is just equal to 9, positive 9. How many people got that all the way through? Amazing. Good job, guys. Okay, so essentially this is the lesson today. It's using the Pythagorean theorem. But now we're going to bring in all the different shapes that have right angles in it that we can use the Pythagorean theorem on. So the first one is a square. So we have to remember the different properties. So it says find the length of the diagonal of a square. So first thing I want to remember is in a square, what do we know about all of the sides in a square? All of the sides are what? Equal. So if one side is 4, do we agree that all the sides are 4? And then it says find the length of the diagonal. Well, I don't have a diagonal, so I need to draw one. And the last thing I have to remember about this square is that all the angles are what kinds of angles? Right angles. Perfect. So now for me to find the length of the diagonal, I'm going to use one of these right triangles. Doesn't matter which one you choose. And I'm going to redraw it. And then I'm going to label 4, 4, and I want to find the diagonal, so I'm going to call that x. And now, since I have a right triangle and I have two sides, I can do the Pythagorean theorem. Do we all agree that the hypotenuse is x? That's C. So now my equation is going to be 4 squared plus 4 squared equals x squared. Well, 4 squared is 16. Another 4 squared is 16 equals x squared. So now we add 16 plus 16 is 32 equals x squared. I'm going to bring this up here. Switch the sides. X squared equals 32. I'm going to square root both sides now. For 32, I'm going to go 16 and 2. And then 16, I'm going 4 and 4. There's a pair. So x will equal 4 root 2. Do you guys see why I had to show you the radicals, how it comes into play here? So when you're asking me, is it easier? It's not really easier because we're still doing all the same stuff, right? We're still bringing it in. All right, number 6 is a little bit trickier. It's being very sneaky. So it says find the length of the square. And what have I given you? The diagonal. Now we need to remember that in a square, all the sides are equal, but do I know what any of the sides are? No, so I'm going to call them all x. Because I know they're the same, so I could use the same variable, but I don't know I don't know how long it is. And I still need to remember that there's a right angle. There's all right angles in a square. So once again, I'm going to do the same thing I did before, where I just take one of the right triangles and use that. So I'll let everybody catch up here. So I chose one of the right triangles. And this time, my C is 10. The hypotenuse is 10. So when I have a squared plus b squared equals c squared, it's going to be x squared plus x squared equals 10 squared. Now we have x squared plus x squared is not x to the 4th. It is not. What is 1x squared plus 1x squared? 2x squared equals 10 squared, which is 100. Before I square root both sides, what should I do before I square root? What do I have to do before I'm allowed to square root? Caitlin? Divide by 2. You got it. So now I'm going to have x squared equals 50. Now we square root both sides. I'm going to break down that 50. I got 25 and 2. 25 is 5 and 5. There's my pair. So I'm going to get x is equal to 5 root 2. Yep. All right, for number 7, guys, it's a rectangle. Do we know that all the angles in a rectangle are right angles? I want you all to try this problem on your own. Try it on your own and then we'll go over it. So you're trying number 7. So just so you guys could all see, I'm going to give you more time to finish up, but this should have been your equation, some format of this. How many people got their setup right? Awesome. All right, go keep trying to solve this and then we'll go over it. All right, let's go over this. So Again, we're going to have to do that pane full multiplication. So we have 5 root 2 times 5 root 2, and 13 squared is 169. Now when we multiply, 5 times 5 is 25. Root 2 times root 2 is the square root of 4. That 4 becomes 2 and 2. So now we have x squared plus 50 equals 169. I'm going to bring this up here. You subtract that 50, you get 119. And now you square root. So x equals the square root of 119. There's no pairs. So you leave it just like that. How many people got that correct? Perfect. All right. Find the perimeter of a rhombus with diagonals 6 and 10. This is the hardest one. The square is really easy to remember. The rectangle is really easy to remember. The other shapes, not so easy, right? So what is it that I want you to remember? That in a rhombus, all the sides are equal. So when it says find the perimeter, if I'm able to just find one side, can I then find all the sides? They'll all be the same number. And now it says the diagonals are 6 and 10. The other thing about a rhombus that you need to remember is the diagonals cut each other in half. So if one diagonal is 6, then you label it split in half 3 and 3. And if one diagonal's 10, then you split it into 5 and 5. Yeah, the diagonals, they bisect each other, so they cut each other in half. So if one full diagonal is 6, then you label it 3 and 3. And if the other one's 10, you label it 5 and 5 because they bisect each other. Doesn't matter. And then the last thing you have to remember is that the diagonals are perpendicular. So we have 4 right angles in the middle of a rhombus. So these are all the things about a rhombus you have to remember. Then remember, the Pythagorean theorem only works on right triangles. But I actually have, if you guys notice here, I actually have 4 right triangles. 1, 2, 3, 4. Do you guys see all those? I have 4 right triangles. So you pick one of them. Does not matter which one you choose. I'm going to choose this top one. And I'm going to redraw it. So now we're going to use the Pythagorean theorem. So we have 3 squared plus 5 squared equals x squared. 3 squared is 9. 5 squared is 25. So then we're going to have 9 plus 25 is 34. And now we square root. There are no pairs in 34. So the side length is 34, but doesn't that mean every side is the square root of 34? Since in a rhombus they're all equal. So what's the perimeter going to be then? Any ideas? 1 root 34 plus 1 root 34 plus 1 root 34 plus 1 root 34. Isn't that 4 root 34? If you add up all those sides. All right, very last problem for today. John walked 3 meters north, 2 meters east, 4 meters north, 13 meters east, and 1 meter north. How far is John from where he started? So whenever you have these problems where they're saying going north, south, east, west, whatever you're going to do, you're going to make a right triangle. On the vertical side of the right triangle, we're going to add up all our north or south. On the base of this right triangle, you're going to add up all your east or west. And this is where he started. This is where he finished. So start, finish, or start and end. We're trying to find that distance, that direct distance from where you started to where you ended, which we're going to call x. So let's see all the north we're adding. John walked 3 north, 4 north, 1 north. What am I going to do you think, with the 3, the 4, and the 1? Any guesses at all? What do you think I'm going to do with the 3, the 4, and the 1? Excellent. We're going to add them. So we're going to say 3 plus 4 plus 1. 3 plus 4 is 7, plus 1 is 8. And then I'm going to look at all my east. 2 east, 13 east. And guess what I'm going to do with the 2 and the 13? We're going to add those. Excellent. So that's 15. And now I filled in my triangle, so what can I use to find x? The Pythagorean theorem. So we have 8 squared plus 15 squared equals x squared. This is where the perfect squares really help. 8 squared is 64. 15 squared, anybody think they remember what 15 squared is? Luciana? Excellent. 225 equals x squared. Now we add 64 plus 225 is 289. I will tell you, 289 is a perfect square. What number times itself gives me 289? 17. 17 and 17. So x will equal 17. So how far is John from where he started? 17 meters. All right, this is where we're going to end. I'm not going to give you any homework because next class I'm going to have you do your homework in class and we'll go over it together just for extra practice.